Okay, looks like a good time to get started again, and this time we're going to be talking again about sort of analyzing graphs, but this time we're going to talk about something very specific. And there is a term we have of a difference quotient as a tool we can use to figure out what a graph is doing. Now, this is very similar to that average rate of change, but we're going to, instead of putting some specific numbers into it, we're going to just use some generic values. And one of the things that we can do to sort of simplify things a little bit is if I start with just some place on here, doesn't matter where it is. I could say, oh, let's just have this value here of x, and I'll call that value a. Now, if I were to look some distance away from that, I'll call that distance h, then this value right here would be a plus h. Well, now I've got, when I look at my y values, I'll have f of a and f of a plus h. So once again, I can figure out my y2 minus y1. So it's that it's again that sort of y2 minus y1 over x2 minus x1. This is that average rate of change. Well, in this case, when I do this, I will end up with something that looks like f of a plus h, this is my f2, or f of x2, minus f of a over a plus h minus a. And you'll notice something funny happens here in the denominator. What this is going to give me is, I'll still have the numerator is going to be f of a plus h minus f of a, but in my denominator, a plus h minus a, the a's are just going to cancel out, so I'm just going to be left with a single h down below. And this formula is what we call our difference quotient. And I'll switch over here to our other page, and I'm going to show you how we can do that for this particular function. So we have a difference quotient and our formula for that is f of a plus h minus f of a over h. Now, for our given thing, I did have a function in mind. So for our example here, we had our function f of x is equal to this negative x squared minus 2x plus 3. So when we think about this, we're going to figure out what our f of a plus h is, and then what our f of a is. Well, thinking about this, f of a is going to be easier to think about. F of a is just where I take all of my x values and I plug in an a. So this is just going to be negative a squared minus 2a plus 3. Okay, that one looks pretty good. Well, what about this f of a plus h? That's a little tougher. F of a plus h means that I'm going to have, everywhere I have an x, it's going to be an a plus h. So this is going to be negative a plus h squared minus 2 times a plus h plus 3. And thinking about this, I'm going to have negative a plus h squared. That's going to be, I'm going to do the opposite of a plus h times a plus h is going to be a squared plus 2ah plus h squared, and minus this 2a plus h plus 3. I'm going to move outside of my little thought bubble here very shortly to simplify. So that's going to end up being... Actually, I'm just going to restart this whole thing. No, I'm not. Never mind. I'm going to have negative a squared minus 2ah minus h squared. Then I'm going to have minus 2a minus 2h plus 3. And that's going to be hard to see right here, but I'm going to rewrite this in just a second. So I'm going to have, when I rewrite all of this, when I take a look at my difference quotient here, that's that f of a plus h minus my f of a all over h. This is going to be, well, here's my f of a plus h. It's this big expression right here. That's that negative a squared minus 2ah minus h squared minus 2a minus 2h plus 3 minus, so this right here is my f of a plus h. Here's my f of a. That's a squared, negative a squared minus 2a plus 3. This whole thing over h. Well, let's simplify. When I simplify this, I'm going to need to distribute this negative in here, so all of these signs are going to change. And when I do this, I'm going to discover that I've got negative a squared minus 2ah minus h squared minus 2a minus 2h plus 3 minus a minus a squared, that's going to be plus a squared, minus a minus 2a is going to be plus 2a, and minus a 3 is just a minus 3 all over h. Well, we should combine some like terms, and when I do this, take a look. I've got negative a squared and a squared. Those terms cancel out. Nothing combines with my 2ah or my h squared, but negative 2a and 2a cancel out. And last but not least, we have positive 3 and negative 3. So I'm left with minus 2ah minus h squared minus 2h. I only have 3 terms left up top. All of this over h. I look at this and I see that I can factor out an h from everything up top. So when I factor an h out of this top, I'll be left with minus 2a minus h minus 2 all over h. And now I can reduce. Remember, I can't just reduce one of these because I've got an addition or subtraction next to the term. Here I don't have an addition or subtraction next to this or this, so this is a factor. This leaves me with just minus 2a minus h minus 2. And this is that difference quotient. You might ask, why are we doing this? And I will say, you will find out when you start calculus, because this is one of your early methods to help you figure out what a derivative is. Alright, that's all I have for right now, so I will catch you in the next video.